In this part of the course, we start by presenting the key clean code principles that help create readable and maintainable VBA code. The principles included in this section are readable names, single responsibility, option explicit always, meaningful comments only, use constants, modular code structure, strong typing, clear error handling, early exit, avoid duplication. After reviewing the list, we now move through each principle with short explanations and direct references to the incorrect and correct examples prepared earlier. Readable names. In the incorrect example, variables x and t are used. These names do not tell us what the values represent, which makes the code unclear. In the correct version, we use names like quantity and price with tax, which immediately communicate meaning. This shows how a simple change in naming greatly improves readability. Single responsibility. The incorrect example contains one procedure performing 4 different tasks. It loads data, validates it, calculates a result, and displays it. This creates a long and tightly packed block of code. In the correct version, these actions are separated into small, focused functions: load value, eval, calculate, and show result. This makes the flow easier to follow and each part easier to modify or reuse. Option explicit always. In the incorrect example, the variables total and total are both used, even though total is a typo. VBA treats them as 2 separate variables because there is no explicit declaration. In the correct example, the variable total is declared using dim, which prevents accidental creation of unintended variables. This demonstrates why enforcing declarations is essential for catching mistakes early. Meaningful comments only. In the incorrect example, the comment increase I by 1 simply repeats exactly what the code is doing. Such comments add noise rather than clarity. In the correct version, the comment explains why the value is being incremented, specifically to skip the header row. This shows the difference between unnecessary and useful comments. Use constants. In the incorrect example, the number 3 appears directly in the condition without any explanation. It is impossible to guess what this number means. In the correct version, 3 is replaced by the constant status schedule. This immediately makes the code clearer and ensures that any changes can be made in one central place. Modular code structure. In the incorrect example, the same formatting actions on cell A1 are written manually: bold font, yellow background, and borders. If this formatting is needed elsewhere, the code must be copied and repeated. In the correct version, all these settings are moved into a single procedure called format header, which can be reused for any cell. This demonstrates how modular code eliminates repetition and creates a cleaner structure. Strong typing. In the incorrect example, the variable result has no defined type, allowing VBA to mix numbers and strings, such as 5 plus 7. This can lead to unexpected results. In the correct version, number A, number B, and result are all defined as long, ensuring consistent numeric behavior. This highlights how explicit types prevent errors and increase predictability. Clear error handling. In the incorrect example, the line "on error, resume next" causes all errors to be ignored, including dividing by 0. This hides problems that should be addressed. In the correct example, structured error handling is used. The code attempts the operation, and if an error occurs, control moves to handle error, where the message is displayed. This approach makes the code safer and easier to debug. Early exit. In the incorrect example, the code checks for a negative value but still leaves space for further execution inside the block, making the logic more complicated than necessary. In the correct version, as soon as an invalid value is detected, the procedure ends immediately using exit sub. This creates a clear and efficient flow. Avoid duplication. In the incorrect example, formatting is manually applied to both A1 and B1 in 2 separate blocks of code. If formatting needs to change later, it must be updated in multiple places. The correct version calls apply header style for each cell, centralizing formatting logic into one routine. This reduces maintenance effort and ensures consistency.
To summarize, each principle is directly illustrated through the incorrect and correct examples provided earlier. By applying these principles, from clearer naming to grouping logic, enforcing declarations, meaningful commenting, modular design, strong typing, and proper error handling, we significantly improve the quality of VBA scripts and make them far easier to maintain and expand.